morning, everyone. Doing fine?
Yes, sir.
Yes, sir.
Okay. So what did we do last time?
Volume of cone.
Volume of cone. Okay. Before the volume of cone, what did we do?
Area of square.
Area of what? Sorry?
Square.
Square. No, we did area of triangle, right? We did area of triangle.
Yes.
With sum of consecutive numbers and area of triangle.
Yeah. And why were we getting sum of consecutive numbers for area of triangle? How were we connecting area of triangle to sum of consecutive numbers? Who wants to summarize that? Yeah. Anyone remembers how we were getting sum of consecutive numbers for area of triangle? No one remembers that? Anyone remembers how to connect area of triangle to sum of consecutive numbers?
Sir, we divide the square into smaller and smaller pieces.
Mm-hmm. And then?
And in
And
first
then
row,
we
we
can-
take one small square, and second row, we take two squares. Similarly,
Yeah. So we look at columns. I think we were looking at columns. So first column, there is one square, approximately one square in the triangle. Second column, there is two squares. Third column, three squares. So if you count the number of that small square, small tiles, then you will get 1 plus 2 plus 3 plus 4. Right? So this was the figure for that.
yes,
sir.
Yes, sir.
Yeah, this was the figure. Or like, let me show the first one, right? Yeah, this was the figure for that, right? So you divide the square into small tiles, and then you take tiles like this, and you will get one tile here, two tiles here, three tiles here, like that. Okay. And then how many tiles did we divide it into? We made it. Does anyone remember how many tiles we made it? Used
Million. Billions, sir.
million, and after that we made it even. We made it n, and we made n very large, right?
Yes, sir.
And then what formula did we get? We got that the area, as when you make n very large, it becomes half times 1 plus 1 over n. Correct? And when n is a million, this 1 over n is very small. And when you make n even larger, let's say you make n as 10 to the power 100, then it will become even more small. It will become like 0.00000001, like 100 zeros and then 1. Very small. So this thing will become very close to how much? Half of 1 plus 1 over n will become, when n becomes very large, how much will this become?
closer to the area
Remember?
of triangle.
Yeah, but how much does it become? What number do you get?
Near to 1.
Yeah, and this half of 1 plus 1 over n, how much does this become? This total thing, how much does it become? Half of 1 plus 1 over
Sir,
n.
near to half.
Yes,
Near
near to half. Yeah, so when n becomes very large, this becomes very close to half. That's how you get. The answer is half. Okay, that's the area of the triangle. And then next, what did we say? We want to use similar ideas to get volume of cone. Okay, and what did we do? We took a cone of height 1 and radius 1, but we made the cones like this, horizontal, like pointing horizontally. Okay, instead of making it vertical, we make it point horizontally like this. And then what did we see? How are we going to connect this to the square thing? How are we going to connect it to the square? So let's go back to this one. Okay, how do you get cone from this triangle?
By triangle, sir.
Yeah, how will you get the cone from that?
Sir, by rolling that paper or the
Yes.
triangle.
Rotating, sir.
Rotating around what? Around which line?
Around
Around which
height.
axis? Huh?
Horizontal.
Horizontal. Which horizontal?
Horizontal.
Upper one, lower one. Which horizontal one? Which boundary do you rotate along? You
Lower
rotate it
one,
around this, the lower one. Yes, you make this as the rotational axis, and you rotate. Okay, so when you rotate, what do you get? You will get a
Cone, sir.
cone. And what will you get because of the square? The square will become what? When you rotate the
Cylinder,
square around
sir.
this?
Cylinder.
Yeah.
Cylinder.
And what is the volume of the cylinder that you will get by rotating this square around this?
Pi r square, sir.
How much is it here? So this is a 1 by 1 square. So how much will it be?
So pi.
Pi.
So pi.
Okay.
Pi.
And now we want to find the volume of the cone. But we don't want to use the formula. Let's say we don't know the formula of the cone. Okay. Then how do we find the volume? So remember, now again we are just, instead of using this straight line, we will use the steps. Okay, like this step. So how will you get the volume of the cone? Just think how we got the area of the triangle. Similarly, you can get volume of the cone. How will you get it? What will happen to each step? This step, and then look at this step. When you rotate each of them, what will you get? So you're rotating this slab here, then this second slab, then the third slab, fourth slab, fifth slab. So you are adding to get the area of the triangle, you are adding the slabs, right? This slab is 1 tile, then this slab is 2 tiles, then this vertical slab is 3 tiles, the vertical slab is 4 tiles, and so on and so forth. And now when you rotate them, what will happen to each slab? So in this figure, there are 6 steps. You're rotating this. What will you get? These 6 steps will become what when you rotate them? Anyone has any idea? How will it look when you take the steps and you rotate it? What will it look? What will each step look like? So remember, in the triangle, we were breaking it up into columns, and each column we were adding up, right, separately. Each column, we get these columns, right? These. We were adding up the area separately. Now here, what will we add up? What will happen to each of these columns? These column slabs. What will happen to each of them when you rotate? Each column is getting rotated. What will happen to that one? When you rotate the whole square, what do you get? Around this axis, what do you get when you rotate the whole square?
Sir, cylinder.
Cylinder, sir.
Now, if you just take this column, this much. Okay, the last column. The last column here has 6 tiles, right? If I just take the last column and rotate it, what do I get?
Rectangle.
Yeah, this last column is rectangle. But if I rotate it, what do I get?
Cylinder. Cylinder only, sir.
Yeah, cylinder. Is it very thin cylinder?
No, sir. It is very thick cylinder.
Thick cylinder. Is it thin in height? Is the height very thin? But here the cylinder is rotated horizontally. So is the thickness in height wise is it small? What is small? Which was small? The cylinder has height and radius. What is small here?
Sir, height. Height is
Height is small, yeah. What is in this case, there are 6. So what is the height of this cylinder? If I rotate this column, what is the height here? How much is this height? This is the height.
So 1 by 100.
Sir, 1.
The height.
One.
This. How much is it?
1.
So 0.01.
The height of the cylinder is how much? Height of the cylinder.
So 0.01.
So here it is 6. So tell me in terms of 6. Actually, there's only, okay, well, let's use 100. Fine. So 0.01. Yes. And the radius is how much?
So
How much is the radius
50.
of the cylinder? Of this. So remember, I'm rotating around which axis? Which is my axis? Where is my axis?
Horizontally, sir.
Horizontally where? Where around which are you rotating? Horizontal where? Like here, here,
X-axis,
here, where?
sir. X-axis.
X-axis. So here below, right? This lower one. Correct? Lower
Yes,
one.
sorry. Y-axis, sir.
Okay, let's see now. So let's try to go back to the now. How do you get a cone? Which are you rotating around? Which axis? Are you rotating around the horizontal axis? So remember, this was the volume of the cone.
Horizontal, sir.
Horizontal.
Yeah, this is the cone that you're getting. Okay. So this is the 1 by 1. You're rotating around which axis? Which axis? Horizontal or vertical?
Lower horizontal, sir.
Lower horizontal. Exactly. Lower horizontal. Okay. And then you're going to divide up this square. It looks a little bit like a rectangle, but actually it is a square. Okay. And dividing it into hundreds, 100 things vertically. And then each vertical column is going to rotate like this, and it's going to give a yeah. So how you're rotating around this axis. So what happens to the last column? Last column, when you rotate it around this axis, what do you get? So this is the axis, and you're rotating this is the last column, right? So you're rotating the last column like this. Okay. Yeah. So this is the horizontal axis. Okay. And you're rotating the last column like this. Okay. So what will you get when you rotate the last column? It'll be a very thin what? Thin cylinder.
Yes, sir.
Which part is thin? The height of the cylinder is thin, or the radius is thin? We have what happens to the cylinder? Are we making the cylinder? Is the cylinder facing standing up, or is it rotated flat? Is the cylinder like, is it kept sideways, or it is kept standing up? The cone is standing up, or is it horizontal, placed horizontally?
Sir,
Standing up.
Horizontal.
Standing up, sir.
yes,
Standing up. Is this look at the cylinder? Is this cylinder standing up, or is it placed
horizontal.
horizontally?
Horizontal.
Sir, it is
It is horizontal. Yeah. So which is the height? The height is vertical or horizontal? The height of the cylinder.
vertical, sir. Vertical, sir.
Height of the cylinder. Tell me which is the height of the cylinder here. Is this the height of the cylinder, or this the height of the cylinder?
That horizontal line.
This is the height of the cylinder. Okay. So normally
Yes,
when you
sir.
say pi r square h, okay, when you say pi r square h, then the height is always the thing between the two circles, right? The gap between the two circles. So here, even though I'm saying height, actually it is the horizontal dimension. Okay. So the height of the cylinder is going to be 1 here. Now, when you rotate the last column, okay, just this last column, okay, you will also get a cylinder, but it will be very thin slice. Which will the height be thin or the radius be thin? Which will be smaller? Height will be small or radius will be small? Do you see the figure here? I'm just rotating this column around this axis. So I'll get a small plate, like a small plate, right? Very thin plate. What will I get? Thin circular plate, correct? What is the radius of the plate? Yeah. What is the radius of the plate? This cylindrical plate. Okay, so it'll be like this. It'll be like a small disc, like a small disc. So what is the radius of the disc of that small thin plate? So I'm rotating this last column around this. So I will get a small cylinder, thin cylinder. So tell me the size of that cylinder. Tell me the radius and tell me the height.
Sir, only last column, no, sir.
Only last column. Yeah. Now tell me when I just rotate the last, if I'm just focusing on the last column rotating, then what shape the shape I'll get is a cylinder. Now tell me the size of the cylinder. Size means like both the height and the radius.
height is 100.
Height is 100. Okay, remember, okay, remember that this is 1. Okay, so let's go back to okay, if this is 100 by 100, then this is 100. You're right. The height, no. Height is 100 or radius, which is 100? Height is 100 or radius is 100? Which is
Radius.
the radius and which is the height?
Radius 50, sir.
Okay, tell me how is
Radius
radius 50?
50.
Sir,
How do you get
diameter is 100, sir. Radius
Diameter
equal to d
100.
by 2, that is 50, sir.
Okay, tell me how is the diameter 100? Where am I rotating? Which is my rotational axis?
Sir, radius is half of diameter, sir.
Okay, let me label the corners. Okay, let me label the corners so you can tell me. So let's label the 4 vertices as A, B, C, D. Okay. Okay, now tell me which is the rotational axis. So the lower one is CD. Okay, I'm putting C and D here. Now tell me what is the rotational axis? Around which line segment are you rotating? Can someone tell me what is the rotational axis?
BC, sir.
BC is the rotational axis. Okay. Now tell me what is the rotational axis? Which is the rotational axis? Let's look at this the way I was showing here. Okay, what is the rotational axis? Yeah, look at this. What is the rotational axis? Which is the rotational axis here?
Radius is 15.9090, sir.
15.90. But can you tell
So
me which is the rotational
0.02,
axis? First, can you tell me what is the rotational axis? Which is the rotational axis? Around which are you rotating? Around which axis? CD, yeah. DC, yeah. This is the rotational axis. You're rotating around this point. If you rotate around this point, from the square, you will get a cylinder of height 1. This is the height, okay? This is the height. From the square, you will get a cylinder of height 1 and radius 1. The radius will be 1 and the diameter will be 2. Okay? And from the triangle, you will get a cone of the height 1. This is the height and this is the radius. BC is the radius. So that will be 1. Okay? And now tell me what will happen to just the last column. Just the last column, when I rotate, what will I get? Will I get a thin cylinder? And if I get a thin cylinder, tell me what is its radius and height. Okay, tell me what if I rotate this last column around DC, what is this height of the cylinder I get and what is the radius of the cylinder that I get?
Height is 1 by 100 and radius is 100, sir.
Yes, you said that if I rotate this last column, okay, I will get a cylinder of height 1 by 100 and radius 1. Can you tell why?
It will be the cylinder of diameter 200, sir, and radius of 100, sir.
Radius 100 and height of the cylinder will be what?
1 by 100, sir.
Yes, 1 by 100. So this is 1 by 1. Okay, remember this AB is 1 and AD is 1. So this is the thickness. This is the thickness of the cylinder. Okay, the thickness will be the height. So it's like a thin plate. This is the thickness of the plate. The thickness of the plate is 1 by 100. That will be the height, and the radius will be BC, which is 1. Okay. So what is the volume of that cylinder?
100 pi, sir.
Okay. So tell me, how do you get? So what did you say? You said the volume of from last column. Okay. You get cylinder of radius 1 and height 1 by 100. Okay. Volume is how much?
Pi into 1 by 100.
Yeah, pi r squared h.
Pi
So it
0.01.
yes.
Yes, sir.
Exactly.
Pi
Into
0.01.
Exactly. Okay. Times 1 squared. 1 squared is 1. Pi r squared h. So pi 1 squared times 1 by 100. Okay. Okay. Now, similarly, if I take each of these different columns, look at all these columns. Okay. All these columns, the first column, second column. So there'll be 100 such columns. Each column, when I rotate, what will I get? And how will what will I get and how will its size keep changing?
Height
So
of
instead
the
of
cylinder.
all the different columns, each column. Let's take the third column. From the third column, what will I get? So it's like I'm getting these different columns, so different columns. Like let's say this is the other different columns, right? So I'm rotating each one. I'm rotating this column, then this column, and then this column. Like there are 100 such columns. Right? The columns are all like this, different columns. I'm rotating each one. What will I get from each one? When I rotate this column, I got a cylinder of radius 1 and height 1 over 100. From the other columns, what will I get?
We will get different type of cylinders with the same height and different radius, sir.
Okay. Okay, Spurti. So, you said you will get different. You will always get a cylinder with same height and different radius. So, will it be same height and different radius, or will it be different radius and same height? Which one will it be?
Same height.
Same height and different radius. Yes. Okay. So because the height is the thickness. The thickness of each column is actually the height of the cylinder, and the radius is actually how tall that column is. Okay, how tall the column is. This tallness is is actually the radius, and this thickness is actually the height. The thickness of every column is 1 over 100. Okay, so the thickness of all the columns is 1 over 100. So the height is all 1 over 100, but the radius is going on changing. How much is the radius? How much is the radius of the first cylinder here? The cylinder that you get from the first column. When you rotate that, what do you get? You get a cylinder with radius how much?
1 by 100.
Yes. Second column? Second column, how much will you get? What is the radius of the cylinder that you get from the second column? Okay, this is the second column. When I rotate this one, what do I get?
2 by 100.
Yes. Third one?
3 by 100.
3 by
Yes.
100.
Yes. So you will get the radius is going on increasing. It is 1 by 100 is the first one, 2 by 100 is the second one, 3 by 100, and the last one is 100 by 100, which is 1. Okay, the last one, the radius is 1. And the height of all the cylinders, height is same as thickness. Okay, thickness of all the cylinders is how much? How much is the thickness of all the cylinders?
1 by 100.
1 by
Yes.
100, sir.
Okay. Now, can someone tell me how you will get volume of the cone, approximately the volume of the cone from this? What will you do? You'll add up what? You will add up all the volume of each of these what?
Each of these
Cylinders.
Yeah, each of these very thin cylinders. You'll get thin cylinders with different radius, increasing radius. Okay, they all have height 1 over 100, and the radius goes on increasing from 1 over 100, 2 over 100, 3 over 100, 4 over 100, like this is 100 over 100. And you will add up all these. So by adding up the volume of these thin slices, the slices are going on increasing in radius. You can get approximately the volume of the cone. Okay, now can someone tell me how to add up? How will I go add up and adding up and simplifying? Can someone tell that? Yeah, tell me how will you add up the volume of the different cylinders?
So volume of each cylinder and into number of cylinders.
Okay, but is the volume of so from the first column, you will get a cylinder of radius 1 over 100. From the second column, you will get cylinder of volume of radius 2 over 100. From third one, you will get 3 over 100. So is the volume of each cylinder same, or is it going on increasing?
Going on
Increase.
Increasing, sir.
Increasing, exactly. So you can't just say it is this multiplied by the, you can't just say it is number of cylinders times the volume of each cylinder, because the volume is going on changing. So what will you have to do? What will you have to do? Tell me the volume of the first cylinder. The volume of the first cylinder. How much is the radius of first cylinder?
1 by 100.
1 by 100.
Yeah. So what will it be? Pi times r squared h. So what is the r? 1 by 100.
1 by
So
100
pi
whole
times-
square.
Pi times 1 by 100 whole squared. Okay. To understand this notation, what I'm writing, 1 by 100 caret is square. Okay. This little vertical arrow, this vertical arrow looking thing is square, is the power to the power. Okay. You understand this thing? Everyone understand this thing? Or anyone is confused about
Yes,
this symbol? Okay. So pi times 1 by 100 square times, what is the height?
1 by 100.
1 by 100.
Times 1 by 100.
1 by 100.
Yes.
We get pi 1 by 100 cube.
Yes. Okay, which is pi times 1 by 100 cubed. Good. Okay. Okay. Now volume of second cylinder is how much? Yeah. What is the volume of second cylinder?
Pi into 2 by
Pi
100
into
whole
2 by
square to 1
100
by
whole
100.
square into 1 by 100.
Okay, so it will be pi into 2 by 100 whole squared into 1 by 100, right?
Yes, sir.
And if I write that as, I can also write that as pi times 1 by 100 cube
2
times
by
what? I write it as pi times 1 by 100 cubed times times what? So let me remove all the 100 outside. Okay, so if I remove all the 1 by 100 outside, I'll get 1 by 100 cubed. And then what will I get from the 2? The 2 will become, because the 2 will become pi times 1 by 100 cube times 2 squared. Correct? Is this correct? Okay. Do you see this? Volume of the first cylinder is pi times 1 by 100 cubed. Volume of the second cylinder is pi times 2 by 100 squared times 1 by 100, which can also be written as pi times 1 by 100 cube times 2 squared. Because I just took the 2 squared outside. Is this clear to everyone?
Yes, sir.
Yes, sir.
Okay. Third one is what? Third cylinder is?
Pi into 3 by 100 square
Pi
into
into
1
3
by
by 100 whole square into 1 by 100.
Yeah. Third cylinder equals, it is exactly the same as before, but I just copy this thing. Yeah, what do I need to change? So what I need to change here to make it correct? Third one?
3s.
3 squares. sir.
3 square, sir.
Okay.
3 squares. sir.
And exactly. What is the volume of the ith cylinder?
What, sir?
Ith cylinder. Ith. So let me make it volume of the ith cylinder. Yeah, what does it be? In general, for ith one, what will it be?
Pi into 1 by 100
Pi
whole
into
cube
1 by 100
whole square.
Ith cylinder. Ith. Okay. I means like I can be for I equal to 1 through 100 like that. So ith one. How much will it be? Okay, let's
Pi
write it
into
down.
1 by 100 whole cube
1/100.
into I square.
Exactly, yes. So instead of this, I'll just put I instead of 2 over 100, I'll put I over 100 whole squared into this, which is equal to, okay, which is equal to, in general, it will be pi into I squared here. Okay, so in general, be this. Okay, so the first one is pi times 1 by 100 cubed. Second one is same thing times 2 squared. Third one is same thing times 3 squared. Ith one is same thing times I squared. And I is going from 1 through 100. Okay, now tell me what will happen if I add up all these volumes.
Volume of the cube. Volume of the cylinder.
Volume of cube. Cylinder, sir.
Volume of which one? Add up all these. The first one is this much. Second one is this much. Third one, second one is this much. Third one is this much. Fourth one will be 4, this time 4 square, and so on and so forth. If I add up all these small cylinders, what will I get? I'll get volume of what? Approximately, I'll get volume of?
Volume of BC.
Cylinder.
Which cylinder will you get volume of?
BC.
100 by 100 cylinder.
Are you going to get the volume of this cylinder when you rotate this square ABCD? Are you going to get the volume of this rotation of the
The
ABCD
BCD.
around DC, or the triangle around the DC? Which one will you get?
ABCD.
So if I rotate ABCD around the axis CD, I will get a single cylinder. And if I divide it up, will I get, when I add up this first column, just this red one, just the red ones, okay, the red part. What am I adding up here? So look at this thing that I'm adding up. Okay. When I say volume of the first cylinder is this much, it is just the volume of the red part here. This red thing here, when you rotate around CD, it'll just be this part's rotation, not the whole, not this full thing rotation. I'm just rotating this part. This part will be pi times 1 over 100 cubed. This will be pi times 1 over 100 cubed times 2 squared. This will be pi times 1 over 100 cubed times 3 squared. Why? Because the radius is becoming double, triple, 4, 5 times. Radius is going on increasing. So when I add up the volume of the cylinder obtained from this first red thing, the second red column, the third red column, the fourth red column, I will get volume of what? Whose volume will I get? So I'm looking at all these red columns, okay? Only the red columns. And I'm adding up the volume of the cylinders obtained by adding up these red columns. Not the whole, not everything here. Am I adding up what I get after rotating everything, this whole thing here, or am I only adding up what you get from these red columns?
Red column.
Only from the red columns.
Only from the red columns. So when I rotate the red columns, what do I get?
Cylinder.
Will
Cylinder.
you get a cylinder? Each column I'll get a cylinder. But when I look at the whole thing, when I rotate all the red columns together, what do I get?
Cone.
All the red columns.
Cone.
Yes. Yeah. So each red columns gives me a thin cylinder. When I rotate all of them together, I get approximately a cone. It's not exactly a cone. Okay. Why is it not exactly a cone? Because I'll get this extra little step, half triangles here. And those are also rotating. So I'm getting approximately a cone. So then by adding up all these things, adding up this pi times 1 over 100 cubed, then pi times 1 over 100 cubed times 2 squared, pi times 1 over 100 cubed times 3 squared, and I squared like that. By adding up all that, I will get the volume of the cone approximately. Now, can someone tell me how do I add this and get the answer? How do I add up all these things? What is the sum of all these things? Does anyone know how to add these things? So I'm adding this. Okay. Plus same thing times 2 squared plus same thing times 3 squared. Okay, I'm adding like that all the way to 100 squared. What will I get? You know how to add this?
So pi into 1 by
The
100
pi
whole
into
cube
1
into
by 100 cube.
1 plus 2 plus 3 so on 100 whole square.
Yes. So I can just remove this 1 by 100 whole cube as a common factor. Okay. And I will get that multiplied by 1 squared plus 2 squared.
So we
Plus-
can take whole square, sir. 1 plus 2 plus 3 so on up to 100 whole square.
Is 1 squared plus 2 squared plus 3 squared till 100 squared, is that same as 1 plus 2 plus 3 plus 100 whole squared?
Yes, sir.
Is it?
No, sir. No, sir.
No. Yeah, I mean, if I can I just say, can I say a squared plus b squared?
No,
Is
sir.
it equal to a plus b whole squared?
No, sir.
Can I take the square outside? No, right? This, when I expand this, I get an extra 2ab term, right? This is different from this. A plus b whole squared is a squared plus b squared plus 2ab. They're not the same. So I have to keep it separate. Correct?
Yes, sir.
So what do I
Yes,
get? 1 squared plus 2 squared plus 3 squared. Like this all the way till 100 squared. Okay? And I cannot write this as 1 plus 2 plus 3 till 100 till that whole square. I cannot do that. Okay? Now can someone tell me how do I calculate this? Does anyone know how to calculate 1 squared plus 2 squared plus 3 squared till 100 squared? Have we done formula for 1 plus 1 squared plus 2 squared till 100 squared? Have we done that formula? Who remembers how to do that? Have you done that formula? Anyone done that formula or not done yet? Nobody's done the formula? 1 squared plus 2 squared plus 3 squared? I thought 9th grade you do the formula, no? Is not taught in school yet? Sum of the squares of 1 squared plus 2 squared till 100 squared. CBSE.
Sir, n
Nobody's done that
square.
formula? How much is it?
N square, sir.
Okay, so I'm asking formula for, so you already know the formula for 1 plus 2 plus 3 till n, right? 1 plus 2 plus 3 till n is n into n plus 1 divided by 2. Okay, but what is the formula for some of the first n squares? So I'm doing 1 squared plus 2 squared plus 3 squared, okay, till n squared. Has anyone seen this formula or it is not done in school yet? Have you seen this formula?
So it is
1 square
n
plus-
square.
Sir, it is n square.
No, sir.
Can it be n squared? See, already it has to be. Can it be n squared? Or it has to be more than n squared. It has to be more than n squared. Why? Because it's n squared already is the last term itself is n squared. So 1 squared plus 2 squared plus 3 squared till 100 squared. Can it be 100 squared or does it be more than 100 squared?
More than, sir.
Yeah,
More than
more
100
than that.
square.
Yeah. So does anyone know the general formula for this? You've not done it in school yet? Not taught in school?
No, sir.
No, sir.
Okay. Let me write down the formula, okay? Or just search online and can someone search online and tell me the formula?
So
Search for
n
the
bracket
sum of-
n plus 1 bracket 2n plus 1.
Okay, repeat that. Tell me again. Tell me n into
n into n plus 1 bracket 2n plus 1
You are forgetting one thing, forgetting something in the middle, in front.
divided by 6, sir.
Yeah, 1/6. 1/6 times n into n plus 1 times 2n plus 1. Okay, who was the person who said that? Can you raise your hand? Okay. Madhumita. Okay, where did you find the formula, Madhumita?
Sir, in Google.
Okay, yes, this is correct. Okay, so the formula for the sum of the first n numbers is n into n plus 1 divided by 2. And the formula for the 1 squared plus 2 squared till n squared is 1/6 n into n plus 1 into n plus 1. Okay. Madhumita, do you know the proof of the first formula? Why is the sum of the first n numbers equal to this much? Do you know the proof? How to prove that? Or do you just know the formula?
Sir, can you repeat the question?
Yeah. So what is the formula for the sum of the first n numbers? 1 plus 2 plus 3 plus 4 till n?
n bracket n plus 1 divided by 2, sir.
Okay. Do you know the proof for that? Why is that correct? Did you do derivation of that formula? Why how you get that formula? Why is it n into n plus 1 by 2?
No, sir.
No? They didn't teach you that? Anyone knows the proof of that formula? Why do you get n into n plus 1 by 2? Okay. Now, nobody knows the proof of this formula. Why is the first sum of the first n numbers this much? Nobody knows the proof? Has anyone done the proof? Or not done? Nobody's done the proof of that one? Anyone knows the proof of that one? Anyone knows the proof of this formula? Okay, fine. We'll look at the proof later. Okay. So for now, just remember this formula, that just as the sum of the first n numbers is n into n plus 1 by 2. Similarly, there is another formula for 1 squared plus 2 squared plus 3 squared till n squared, and that is 1/6 n into n plus 1 times 2n plus 1. Okay. So now tell me, how much will this be? So volume of all these cylinders, you can use this formula. Okay. You can use the formula. So what will be the volume of all these, this thing? All these 1 squared plus 2 squared is 100 square. How much will that be?
So pi into h cube into 1 by 6. So this formula.
Yeah. So you'll get the 1 by 100 cube there, and then you will get from this. Sorry, this times what will be this much? This 1 squared plus 2 squared is 100 squared will be how much? Into 1/6 times. Can you tell me what will you keep getting? 1/6 into? I have to put n equal to 100, correct? 1 squared plus 2 squared plus 3 squared till 100 squared times 100 into 100 plus 1 into 2 times 100 plus 1, correct?
Yes, sir.
Okay. Now tell me, how much is this? How much is close to approximately what? So I have 100 here. So I have 300 in the denominator here, right? I have 1 by 100 cube. And I have 100 here, and this is 100 plus 1, and this is 201. Okay. So it is here this much, 100, and this is 101. And then this is a 201. Correct? Tell me how much is this approximately?
So 3,38,350.
How did you get that 3 lakh something? Can you tell them?
So when we multiply 1 by 6 into 100 and 101 into 201, sir.
Oh, okay. Well, you get that much 3 lakh. Okay, let's just check that. Okay. We'll just do that on somewhere on a calculator and let me just check that. Yeah, you get 3 lakh 38. Wait, what did you say? How much did you get? Yeah, 3,38,350. Okay, correct.
Yes, sir.
So approximately how much is this? 3 lakh something divide, and then you are dividing it by 1 by 100 cubed. How much is that? Okay, so you are getting pi times 1 by 100 cubed. Times 3,38,000 338,350. Okay, 335,380. Okay, tell me how much is this? Pi times 0. How much is it? Pi times 0.3358. Okay. So is this very close to 1/3 pi? What is this close to? What is 1/3 pi? How much is 1/3 pi if you write it in decimal? Okay. How much is 1/3 pi? 1/3 is how much? If you write in 1/3 in decimal, how much will it be?
0.3 bar.
Yeah.
0.33, sir.
0.333333 like that. And here you're getting 0.3358. So it's very close to 0.33. Now, can someone tell me without actually multiplying this, getting this 33 lakh, 3,35,000, can you just look at this formula here and tell me why it is close to 1/3? Let's look at this. Just look at this expression here. Once again, yeah, look at this expression. Tell me why is this close to 1/3 pi? Look at the 100. You have 100 in the numerator, that will cancel away. You have 101, another 101 in the numerator, that is very close to 100. It almost cancels with 100. And then you have a 201 in the numerator. It almost cancels with 100. Can you tell me why, by looking at that blue formula what I've highlighted, why it is close to 1/3 pi? Who can tell why this is close to 1/3 pi? Just try to cancel the hundreds. Try to cancel the hundreds. How will I cancel the hundreds? Anyone? Anyone wants to give it a shot? Try simplifying this and seeing why it is close to 1/3 pi. Who wants to try this? I can help the person. Anyone wants to try cancelling the numerator and denominator approximately? Just look at this. Okay, I can take this 100. I can take the 100 in the denominator and I can write it as equals pi times 1/6. I bring the 1/6 to the front. I take the 300. The 100 is the denominator. I can take it 100 divided by 100. That will cancel away. Okay, and then I will take the 101. Then I can divide that by 100. And then the 201, and then divide that by 100. Look at this. I've taken the 300 and I cancelled the first 100, and I can just get 101 divided by 100 and then 201 divided by 100. Do you see this? Now, can someone tell me why this is close to 1/3? 1/3 pi? Who can tell me why this is close to 1/3 pi? Anyone? Anyone see why this is close to 1/3 pi? What is 101 divided by 100? How much is 101 divided by 100? And what is 201 divided by 100? Just look at this. How much are these? How much is this thing? Approximately. Approximately how much is 101 divided by 100? How much is approximately?
1.01.
1
1.01.
plus 100.
1.01. And how much is this 201 divided by 100?
2.01.
Yes. Yes. So this is pi times 1/6 times 1.01 times 2.01. Okay. Now can you tell why this is close to 1/3 pi? Why is this close to 1/3 pi? Who said 1.01, 2.01? Can you raise your hand? What is 1.01 close to? And what is 2.01 close to? 1.01 is close to?
1.
Yeah. 2.01 is close to?
2, sir.
2. Exactly. Yeah. So if this is very close to 1, and this is very close to 2. So this whole thing is very close to 1 time. It's very close to, okay, is close to pi times 1/6 times 1 times 2. Okay, which is 1/3 pi. Okay.
Yes, sir.
So do you see how by rotating, what did we do today? We rotated this square and these red slabs, columns, and by rotating that we got a cone or approximately a cone, and we can figure out the volume of the cone by adding up all these thin slices, cylinders you will get. So these thin cylinders we add up, and we took 100 of them, and we found that the volume was exactly volume of the ith cylinder was pi times 1/100 cube times I squared. So we just add up, by adding up all 100 of them, we'll get pi times 1/100 cube times 1 squared plus 2 squared plus 3 squared till 100 squared. And then we use this formula for the summation of the first n squares, not the summation of the first n number. The squares of the first n squares of the first n numbers, sum of the first squares of the first n numbers. And by putting that formula, we saw that it is very close to pi by 3, because it is actually exactly pi times 1/6 times 1.01 times 2.01. Okay, everyone understood this part, this much?
Yes,
Any
sir.
questions before we close? Okay. Okay, I think you have to go, right, for your mentor meeting. Is that correct?
Yes, sir.
Okay, thank you so much. Bye.
Thank you, sir.
Bye.